This lesson is a quick review on how to simplify fractions that contain radicals and square roots. First off, if you have a fraction that has radicals or square roots in it, you could treat it as if the entire fraction is inside of a square root. In other words, you can focus on the numbers in the fraction and see if that fraction simplifies before you do anything else. 50 over 98 does simplify because they can both be divided by 2. 50 divided by 2 gets you 25. 98 divided by 2 gets you 49. Now that you've simplified the fraction, you can square root each number in the fraction. Square root of 25 is 5. Square root of 49 is 7. Done. That is your answer. Try the same process with question 2. Since both your numbers are inside square roots, you could treat it like the whole fraction is inside the square root, simplify the fraction, then find the square root of both those numbers. For 2, both the numbers in your fraction can divide by 3. Oh, and both 4 and 9 are perfect squares. They both square root really well. You get 2/3 for your final answer. Sometimes only one number in your fraction is a square root number. When that happens, you cannot divide square root numbers by normal numbers. So we cannot divide 54 by 3 because they're different types of numbers. So instead of trying to simplify the fraction, you're going to try to simplify the square root. Focus on the square root of 54 and make a factor tree to simplify. When you simplify that square root, you can list out all of the prime factors that multiply together to make 54 and circle pairs of the same number. Pairs of numbers that are circled represent a number that escapes the square root. And then if you have multiple numbers inside of the square root, they get multiplied back together. So that square root of 54 simplifies to 3 square root of 6. So let's replace that square root of 54. Now your fraction looks like this. I want to point something out. While we cannot divide square root numbers by normal numbers, we can divide other normal numbers by normal numbers. 3 divided by 3 gets you 1, or you could think of it as just anything divided by itself cancels out. And 1 square root of 6 is really just square root of 6. That's your final answer. Imitate that process for question 4. Simplify the square root first before you do anything else. So when you list out the prime factors for 56, you have one pair of 2's. So square root of 56 becomes 2 square root of 14. Replace square root of 56 in the fraction with 2 radical 14. Oh, the 2's cancel out. Square root of 14 is your final answer. So your key takeaway is that while you cannot divide square root numbers by normal numbers, you can divide other normal numbers by normal numbers. So if you simplify the square root and there's a number in front that can actually divide, do so. Try the same process with question 5. Simplify square root 20. Square root of 20 should get you 2 square root of 5. So when you replace square root of 20 in the fraction, it looks like this. Now, when you focus on the normal numbers part, 2 over 8 doesn't divide perfectly, but 2 over 8 does simplify to 1/4. So for your final answer, replace the 2 over 8 with 1/4, but keep the square root of 5 where it is. And if you have 1 times anything, then multiplying by 1 doesn't really change your answer, so you can leave that out. The simplest way to write your answer would be square root of 5 over 4. Try that process with question 6. Square root of 45 becomes 3 square root of 5. Replace square root of 45 with 3 square root of 5 in your fraction. The 3 over 6 part simplifies to 1/2. So you've got 1 square root of 5 over 2, or just square root of 5 over 2. Now, sometimes your square root in the fraction is under the fraction bar. There's one of the key rules of how you write your answer to radical expressions in math is that you cannot have a square root below your fraction bar in your final answer. So while the first part of the problem will be similar to what we did before, there's an extra step at the end to rationalize the denominator and cancel out the square root under the fraction. So step 1 is still to simplify the square root part of your fraction. So square root of 18 is really 3 square root of 2. So now your fraction looks like this, 11 over 3 square root of 2. But that's not our final answer because we cannot have a square root of 2 under the fraction bar. On top of the fraction bar is okay, but your final answer cannot have square roots under the fraction bar in the denominator. So you rationalize the denominator. To do that, you multiply by the twin square root of the one you want to cancel out. So if you have a square root of 2 under the fraction bar, you multiply by a square root of 2. But whatever you do under the fraction bar, you have to do above the fraction bar to keep it balanced. So you multiply square root of 2 on top as well. Now 11 times square root of 2 don't really multiply together because one's a normal number, one's a square root number, so they just stay separate. But underneath the fraction bar, those square root numbers can multiply together, so put them inside the same square root. Or you could write it as square root of 4 if you so choose, but I like to write it like 2 times 2 because then I immediately see I have a pair of numbers that I can circle inside of that square root, so that square root of 2 times 2 becomes a normal 2 without a square root sign anymore, since everything inside the square root paired up and escaped the square root. So under the fraction bar, I now have 3 times 2, or just 6. So your final answer is 11 square root of 2 all over 6. Question 8, go ahead and simplify square root 20. Square root of 20 becomes 2 square root of 5. So when you rewrite your fraction, it should look like this. What would you multiply on top and below the fraction bar to rationalize the denominator? Square root of 5. You multiply by the twin square root of the one you have under the fraction bar and want to cancel out. So on top of the fraction, you just have 7 times square root of 5 because those can't combine. But under the fraction bar, that multiplication of 2 square roots can combine. But if you have a circled pair of numbers inside of a square root, that represents a number that escapes the square root. So under the fraction bar, you now have 2 times a normal 5. 2 normal numbers can totally multiply together. 2 times 5 gets you 10, so your final answer is 7 square root of 5 all over 10. Go ahead and rationalize the denominator for number 9. Simplify the square root first. Square root of 8 becomes 2 square root of 2. Now when you rationalize that denominator, by multiplying by the twin square root of what you already have under the fraction bar, it should look like this. Well, if you have a pair of 2's inside of a square root, that becomes just a normal 2 outside of a square root. But look, you're not quite done because the normal numbers that are not inside square roots can actually simplify. 12 divided by 4 gets you 3, so 3 square root of 2 is your final answer. Try question 10. So square root of 12 simplifies to 2 square root of 3. So you multiply square root of 3 above and below the fraction bar. You should get 10 square root of 3 over 6, but 10 over 6, that fraction partially simplifies. Both 10 and 6 can divide by 2. So it becomes 5 over 3, and the radical 3 just tags on after that rest of your answer.